Hey everyone, in this video we are going to look at multiplying and dividing polynomials by a constant and then multiplying and dividing polynomials by another monomial. So here we go. We're going to start with the distributive property and then we'll look at quickly how to do it with algebra tiles as well. Okay, so here we go. The distributive property, well, what is that? Well, that's just an algebra property which is used to multiply a single term and two or more terms inside a set of parentheses or brackets, as I like to call them. Okay, so, and you can see this example right here. This is a case where you would use the distributive property. And think about it like distributing the number that's outside of the brackets. So let me grab my trusty pen here. Okay, so first what we're going to do, as you can see it's already outlined by the arrows, is you're going to distribute the 5. And remember, a number that sits outside of a bracket like that with no operation in between, that means multiply. Okay, just the same as when it's bracket to bracket, that means to multiply. Okay, so what we're doing here is we're taking this -5 and we're multiplying it by the first term, then the second term, and then the third term. Okay, so our first term here is going to be our -5 multiplied by 4e squared, as you can see right here. Second term, -5 multiplied by, and remember when you take a term from a polynomial like this, you take the symbol to the left. Okay, in this case there was no symbol, so it's assumed to be multiplication. In this case, that's why they brought down the -5e. Now, the last term here is going to be -5 multiplied by that +3. Okay, that you can see there. Um, in most cases, I would not write this step out. I just picked this example to show you guys what's going on here. Normally, I would just do this in my head. Okay, and feel free to do it in your head or with a calculator as well. I just say -5 times my 4e squared. Now I'm just multiplying the coefficients in this case because I'm only multiplying by a constant here, so it doesn't matter. So I'm just doing a number times a number, okay? In this case, in this case, in this case. So my first one here, -5 times +4, I would just say, well, that's a -20. And I would just put it right there. I would skip these two steps here. And next in my head, I would say -5 times a -5 gives me +25. Okay, and I'm just adding whatever variables I'm left with here. Okay, so this gives me a plus 25e, and then a -5 times a +3. The symbols are different, so it's going to be a -15. Okay, and that's pretty much all that's to it to distributive property. Here's another quick example using the distributive property model. I multiply my first terms, so a -5 times a -2 gives me a 10, and my d squared just stays the same. Excuse my writing. Now my second term is -5 times the -3d, so it's going to give me a +15, and I'm just multiplying by a constant over here. There's no letter, so I just stick with the d. And then my third term here, I'm going to say -5 times a +6. 6 times 5 is 30. Mixed symbols, so it's negative. And that's my answer. 10d squared plus 15d subtract 30. Another way to multiply polynomials by constant is to use algebra tiles, as you can see here. So what you do in this case is you look at what's in the parentheses. Okay, so we look at our 2b squared. We know that b squared is going to be our big blocks, just the same as it's been through all the Unit 5 and Math Makes Sense 9 workbook. So the big ones are the b squared. The long ones are just a variable, which would be b or x, whatever letter they're using. And then the small ones are just the constants, okay? The dark shaded ones are negative and the white are positive, okay? So all they've done here is write out in whatever's inside the brackets here, okay? 2b squared minus b plus 1, okay? Now they wrote this out once, twice, 3 times because they want to multiply this polynomial by 3. So all we've done is we've just assigned tiles to what's inside the parentheses and wrote it there however many times it indicated here to the distributive property. So you can do this through the distributive property method if you find it better, or you can use algebra tiles. It's just 2 ways of doing it, okay? In this case, if you do use algebra tiles, you would just count what's left over here. All right, so you'd still get the same answer of the distributive property model, which give you 6b squared, subtract 6b plus positive 3. Only all you did here was you drew the tiles and then you counted them. You counted 6, you counted a negative 6, and you counted a plus 3. Okay. And this is the last multiplication topic I want to do before moving on to division. This is multiplying a binomial by a monomial. Okay, so multiplying polynomials by monomials. So far we've only covered multiplying it by a constant, okay, which would just be a number. Now this is a number with a letter times another number with a letter, okay? Now, nothing changes as far as the distributive property goes. We still do 7x times 4x, which is written here, plus 7x times 5, which is written here. Okay? So the only difference now is we're multiplying letters or variables. Okay? So I just do my numbers normally. Okay? 7 times 4 gives me 28. Now, x times an x, that just gives me an x squared. Okay, so I'm left with 28x squared. And over here, I have a letter and a number multiplied by just a number. Okay, so I just do my numbers as normally. 7 times 5 gives me 35. And x times no letter, I'm just going to be left with x. Okay, so, so x times x gives me x squared. X times just a number will just be x. Okay, let's look at it for b. S times negative 3s will give me negative 3s squared. It's supposed to be an s. There we go. Plus s times 4 is just 4s. That's it. Pretty simple. And the last one here, negative 9r times 4r will give me negative 9 times 4 is 36. And then negative 9 times a negative 5. Don't forget the negative. 2 negatives make a positive when you're multiplying. And 9 times 5 gives me 45. And it's a 9r times just a number, 5. So we're just left with the r. And actually, this is supposed to be 36r squared. Sorry about that. So that reads 36r squared plus 45r. Okay, moving on to division. So division here, we are going to first look at how to divide a polynomial by a constant, so just a number, symbolically. Okay, so without the tiles. So quite simple really. You divide each of the terms by the number indicated in the denominator. Okay, so in this case, we break it up into 12 divided by 4, and of course this is r squared, and then 8 divided by 4. Okay, so I'm just drawing out what's already here. I'm just separating it, okay? So we just say 12 divided by 4 gives me 3. And there's no letters in the denominator to worry about. So it just remains at r squared. And we add 8 divided by 4. 4 goes into 8 twice. So my answer is 3r squared plus 2. I normally, again, I do not include this step. I would just do this in my head and say 12 divided by 4 gives me 3. I'm left with r squared. 8 divided by 4 gives me 2, and there's no letters to worry about. Let's look at one more example here real quick. Okay, so here we go. Let's solve this one. So you see that we have 18 v squared minus 6v plus 12 all over 6. So each one of these terms is going to get divided by 6. And in my world, I never write them out. I just do it in my head, okay? All I'm doing here is dividing each one of these terms by 6, okay? So remember, there's no symbol here. It's assumed to be positive. 18 divided by 6 gives me 3. And again, I'm just dividing by a constant, so there's no letters to worry about. None of them are affected. Okay, negative 6v divided by 6 is just going to give me 1. I don't need to write my 1s, so I'm just going to say subtract v. And then I'm going to be left with 12 divided by 6, which is 2. So 3v squared minus v plus 2. Okay, moving on. Let's very quickly look at dividing with a monomial. Okay, so not just a letter on the bottom anymore, or sorry, not just a number on the bottom anymore. We get a number and a letter. So all we do is divide our coefficients as we normally would. 12 divided by 4 equals 3. Now v squared divided by v, all we do is subtract the exponents on the letter. So v is assumed to be v to the 1. So a v squared divided by a v is the same as 2 minus 1. Okay, I'm just subtracting my exponents here. So all I'm going to be left with is 1, which is the same as v. Okay, so v squared divided by v is just v. Same thing as this question over here. 15 divided by negative 3, of course, gives me a negative 5. And then w squared subtract w to the 1 is just going to give me with a w here. Okay. Applying this to a polynomial, we do the same thing. This term is just divided by the term on the bottom as well as this term. Okay, if there's 3 terms, we divide each by the denominator. So this just works out to be 18 divided by 2, which gives me 9. Y squared divided by y, as you guys know, it's just y now. I'm left with 12 divided by 2, which gives me 6. And a y divided by y, well, in that case, they just cancel out. So I'm just left with 9y plus 6 in this example. That's all for this week's video, guys. I know it's a lot to digest. If you need some extra help, please come and see me. I highly recommend doing the work in your workbook before attempting the quiz. Remember, you get 2 attempts and only your highest mark will count. If you're not happy with your first attempt, come see me and I will gladly give you a review and a hand with the second attempt. Okay, good luck, guys.